In this video, we're going to be looking at what an isotope is, but before I actually give you the definition, I want you to look at these three isotopes of hydrogen that we have on the screen. And in your guided notes, I want you to use the pictures to find the mass numbers for each isotope of hydrogen. So pause and do that right now. Okay, so the first one is protium. This is still hydrogen. It just has a different name to it. And the mass number is going to be 1 because we have 1 proton in the nucleus. The second one, we have a proton and a neutron in the nucleus, so our mass is going to be 2. And then the last one, tritium, has 2 neutrons and 1 proton, so that's 3 things in the nucleus. So our mass is going to be 3. So we have 3 isotopes of hydrogen here. So you can probably figure out right now that an isotope is 2 or more atoms that have the same element but different mass numbers. So what that means is that the atomic number or the number of protons are all the same. So the 3 hydrogen isotopes are right here again. They all have 1 proton, but their mass is different. And their mass is different because they have a different number of neutrons. So the first one has 0 neutrons, the second one has 1 neutron, and then the last one has 2 neutrons. And that is what makes it an isotope. So same element, different mass number. So there are a few different ways that we can write the names of isotopes so that we don't think that they're all the same version of the element. So sometimes they have really specific names, like protium, deuterium, and tritium for hydrogen. But oftentimes you'll see what is like the setup like that. So what that is X is going to be, should do that in a different color. X is going to be your element symbol. So the symbol of hydrogen is H. So that's why there's an H there. A is actually going to be your mass number. So the first one had a mass of 1, the second one had a mass of 2, the third one had a mass of 3. And you can see all of those numbers in the top of that notation. And then the bottom number for all 3 of these is the same. So you could probably guess that that is actually your number of protons or your atomic number. So that is a common notation that you'll see when we are writing isotopes, is to write it like that. The other way is to write the element dash and then A, which we know A is our mass number. So for example, instead of writing protium, I would write hydrogen dash, and then the mass number would be 1. And it doesn't always have to be the full element name. Sometimes it could be like H-1, the symbol. So those are just different ways that you will see isotopes being written. So example problem number 1, I want you to write the isotope notation for 2 carbon atoms. One has a mass of 12 and one has a mass of 14. So go ahead, pause right now and try this yourself. And then when you are ready to check your answers, make sure you hit unpause. And if you got anything wrong, make sure you correct it. So go ahead and pause right now. Okay, we are going to review the first example problem, writing the isotope notation for 2 carbon atoms, one with a mass of 12 and one with a mass of 14. Before we even can start writing the notation, we need to get the symbol and the atomic number for carbon from the periodic table. So our symbol for carbon is just a C, and then our atomic number is going to be 6. So for each of these, we're going to start with our symbol. And then we know our mass number goes up top. So I'll do 12 first and then 14 on the other one. And then your atomic number on the bottom. So this is one answer that you could have, or you could write it like carbon dash 12 or carbon dash 14. So either of those are acceptable answers for writing the isotopes of carbon. The second one we're going to do is which of the following is an isotope of boron 11? So you have four answer choices right here. Oops. I want you to pause the video and go through them. And when you are finished, you can hit unpause and check your answers. So for this question, our answer is going to be C, boron 10, and I'm going to walk through why the other ones are incorrect. So we know an isotope has to be the same element. So if we go through these choices, option B is not the same element. So we can immediately cross that one out. The others are all boron. And then the second part of that is different mass number. So the first one is boron 11, which is the same exact thing that is in our question. So that can't be an isotope if it's the same uh, atom. And then D is just a different way to write boron 11 using the symbol instead of the name. So that can't be it either because it's the same exact thing as what they're asking for. The answer is going to be C, boron 10, because it is the same element, different mass. Okay. So just a quick summary before you go. Isotopes are atoms that have the same element but with different mass numbers, and that's because your number of neutrons change. So looking at the top, we have two isotopes of carbon that we saw from example number 1. Same element, same atomic number, but different mass numbers. And then when you are writing the names of isotopes or the notation for isotopes, they're always represented by the element, so either the symbol or the name, like they are here, and the mass number, because the mass number is what is different about them. So for the bottom picture, we have two ways to write carbon 14. The one with the mass number and the atomic number, and then one with just the mass number. So make sure all of your guided notes are complete. And then when they are done, you can move on to the next activity.